This is a video for conditional probability. And so let's do just a really quick review of probability. So let's consider tossing two coins and writing down the outcomes we can get. So we could get a head and a tail, or a tail and a head. These two things are different. Or a head and a head and a tail and a tail. And I think last year when we talked about events like this, we sometimes used a tree diagram. So we would say, okay, on the first coin, we could get a head or a tail. And then on the second coin, we could get a head or a tail. Head or a tail. And so we could get our outcomes by going along the branches and saying, okay, head, head, that's one. Head, tail, that's one. Tail, head, that's one. And tail, tail. Okay, I'm debating or talking too much about this. Anyway, there's four outcomes. Now, once we figure out the outcomes, we can say something like, what's the probability of getting one tail? We could say, well, these two have one tail, so it's 2 out of 4, or 1/2. Okay. Now, let's consider some conditional probability. So the idea of conditional probability, let's say, we think about only those outcomes that have at least one tail. Okay, so I might go, the probability of getting one tail, given that, this is a little line that means given that, we're only considering outcomes that have at least one tail. And so I'm kind of making it so that my outcomes are reduced. Okay, so my outcomes are reduced. So the outcomes always go on the bottom. This was 4 outcomes. So I want the outcomes that have at least one tail. Well, that's this one, and this one, not that one. So now I have 3 things that I'm considering. So whatever's back here goes on the bottom. And one tail, well, that's those 2. So now it becomes 2 out of 3 for that probability. Okay, let's look down here at this example. So it says, the table shows survey results of 100 people. And they've asked them about their food choice when eating in a cafe. And they've got males, 56 males, 44 females, so the totals are on the end here. And 43 people say that they eat vegetarian, and 57 people say not vegetarian. Now, this is a common thing that we use in maths when we have, V representing vegetarian and V dash represents not vegetarian. Kind of common, okay? So let's look at this. It says one person is selected at random from those surveyed. So out of the 100, that's the total. And we are trying to figure out from this table this. Maybe you remember from last year. I'm going to write this again. The probability of M intersect V. So this means what's the probability that we've chosen a male that is also a vegetarian? Well, those people live right there. So that's 18 out of 100 for that probability, the number of them out of the total. B says, what's the probability that I pick a male, given that I'm only thinking of vegetarians? Okay, remember, this now becomes the denominator. So the total of vegetarians is right here, 43, and the male vegetarians is here. So 18 over 43. And then C says, what's the probability of not vegetarian given that I pick females only? Well, the females are here. There's 44 of them. So I'm going this way this time. The total females is 44. And the ones that are not vegetarian are right here, 19 out of 44. I probably would reduce that, but I'm not going to worry about it right now. And D says, what's the probability that somebody's a vegetarian? Well, here's all the vegetarians, and that's out of 100 people. Oh, sorry, 43 out of 100. Okay, easy enough. That's good. All right, let's look down here and talk about a formula for conditional probability. The formula is this. It says the probability of A given B is where I take the probability of B, we've already talked about that, and I do the probability of the intersection of A and B up here. So let's just check and see what we did above. Okay, so I want the probability of M given V. I did that right here, M given V. So let's see, that's the probability of V on the bottom. Well, the probability of V was 43 over 100 over, and on top, I need male vegetarians. Male vegetarians. Well, that was right here. Where males and vegetarians meet. That was right here. Okay, the intersection of those two. And that was 18 over 100. And if I divide that, 18 over 100 times 100 over 43, I get 18 over 43. Keep, change, flip there. And was that the probability? It was. Okay, so that formula worked for the things that I did up there. Okay, multiplication of probabilities. Well, if this is equal to that's the formula, then I could multiply on both sides by that, and I could say, okay, the probability, and I can write this B intersect A or A intersect B, doesn't matter. I could write it like this. It's the same thing. And I can multiply by that. And get that formula just by solving that. I'm going to pause for 1 minute.